In this video, we're going to go over the rules for naming alkanes, a homologous series of organic compounds, and we're going to look at some specific examples. So let's just jump right into it. Now, there's a series of rules for naming alkanes, and we'll sort of see these in action in some examples. But let's just go through them quickly, just so we kind of know what we're dealing with here. The first step we want to do is find the longest continuous carbon chain in the molecule. Keep in mind that that's not always going to be a straight line. So I'll show you some tricks as we look at some examples. Then we're going to choose the appropriate prefix that corresponds to the number of carbon atoms in that longest continuous chain and add the ending ane to indicate it's an alkane. Then we're going to look for substituents groups. So these are alkyl groups that are attached to the longest possible chain. We're going to number the positions of those substituent groups using a combination that has the lowest individual numbers. So it's not a sum, but it's really looking for that lowest possible combination of numbers. We're then going to use a prefix if needed to indicate the number of each substituent present, and then arrange the names of the substituent groups in alphabetical order. And that ignores prefixes we use in step 5. Okay, so that's a lot of rules, but let's kind of go through and use them as we look at some examples. Before we get there, though, we do have to talk about some of the prefixes and other names that we need for naming alkanes. So prefixes for the longest continuous chain are the first 6 carbons are listed here. So if you have 1 carbon, you'd use meth, 2 carbons eth, 3 carbons prop, 4 carbons but, 5 is pent, and 6 is hex. For substituent groups, depending on what's attached, if you have a CH3, that uses the 1 carbon prefix and adds YL to it, so it's methyl. The 2 carbon group, so CH2, CH3 attached, uses the 2 carbon prefix, so that's ethyl. And then 3 carbons is propyl. And if we have more than one of those substituent groups, we sometimes need prefixes. We're going to use di for 2, tri for 3, and tetra for 4. So keep these handy because we will need them as we go through and do our naming. So let's look at our first example here. The first sort of step is we need to identify our longest carbon chain. So a good idea is to take a highlighter or a pen and you're basically tracing the longest possible chain without lifting your pen. So if we start at the end here, we got 1, 2, 3, 4. Now you've got a branch here. You could either go up or down. It doesn't really matter. You're going to end up with the same, so I'll just go straight across. Okay, so that is 1, 2, 3, 4, 5 carbons long. So we're going to use our prefix of 5, which is pent, and we're adding the ending ane to it, so indicating it's an alkane. Now, we do have a substituent group, so anything that we didn't identify as the longest chain is a substituent group. It's a branch, otherwise known as a branch. So I'm just going to highlight that in red there. And then our rules say we need to number our carbon chains to give our substituent groups the lowest possible combination of numbers. Since we have only 1 here, and we can either choose to start numbering from this end here or this end here. If we start from this end, it gives our substituent group the lowest possible number. So I'm just going to number those 1 through 5, meaning that we have a 1 carbon or a methyl group attached to carbon 2 of our longest chain. So we need to add that to the beginning of our name. We're going to go 2 and then dash methyl propane. So anytime you have numbers, they're always indicated before sort of the letters and the names, and they always have a dash between them. So this would be 2-methyl pentane. In our next example here, let's take a look. There's a few ways we could kind of start numbering or finding our longest chain. We could start from the carbon at the top, the side, or the bottom. Really, it doesn't matter because any which way we go, we're going to end up with a 4-carbon chain. So I'm just going to go through the middle here just to make it easier. We could have gone from the bottom or the top though. Either way works. Okay, so we have a 4-carbon chain. So we need the prefix but, and we add the ending ane to indicate it's a butane. And then we're going to look at what else is attached to that. We have a CH3 here, a CH3 here. We have to decide how we want to number our main chain. And if we go from left to right, it's going to give those 2 methyl groups the number 2, which is exactly what we want. So we have methyl groups. Let's add that in there. And we have to indicate we have 2. So we're going to use the di prefix in front of the methyl. And then we need to say where each one is. So instead of just saying 2-dimethylbutane, because we have 2 of them, we're going to do 2, 2 dash dimethylbutane. So indicating where each one is, it's separated by a comma, and then numbers are always separated from words with dashes. So this is a 2,2-dimethylbutane. Okay, example 3. So looking for our longest chain, if we kind of start at the end here, we can go 1, 2, 3, 4, 5. But then I can still go down and not lift my pen and get 6. So be careful because not always, the longest chain is not always in a straight line like this one here. So we have a 6-carbon chain, which is hexane. And then we need to decide which end to start numbering from. If we start and go from right to left, it's going to give our substituent group of our methyl here, the number 3, which is lower than if we started from the other end. So this one is a 3-methyl hexane. Okay, example 4. These are getting a little bit more complicated, but that's okay. We're just going to follow our rules. So trying to find our longest chain, we could start here or here. So let's maybe start from the bottom here. We'll go up 1, 2, 3. Now we have a choice, right? We could go down or we could keep going to the side. Either way, you're going to end up with the same numbers. So I'm going to go 5 and then 1, 2, 3, 4, 5, 6. So there's 6 carbons here. So again, that's a hexane. And then we need to take a look at what we have attached to that. So we have a methyl group here, and then we have an ethyl group here. We haven't seen an ethyl group yet. So we want to think about which way do we want to number this? Well, if we start from this end, we'd end up with 1, 2, 3, 4, 5, 6. So that's going to put our substituents at 2 and 4. If we went the other way, it would be 1, 2, it'd be at 3 and 5. So 2 and 4 combination is lower than 3 and 5. So we want to go with our initial numbering starting from left to right. Now we've got a methyl and an ethyl group. And when we have different groups, we need to start with the one that comes first in alphabetical order. So this is going to be a 4-ethyl -2 -methyl hexane. Okay, so E comes before M. So we need to make sure that we are naming it with the ethyl first, followed by the methyl. Okay, last example here. Finding our longest chain is actually just straight across here. And we've got 1, 2, 3, 4, 5, 6 carbons. And then we have a methyl here, here, and here. So if we number it, I think if we go 1, 2, 3, 4, 5, 6, that's going to give us lower numbers. Then if we were to go the other way, 1, 2, 3, 4, 5, 6. So using the blue way would give us a 3, 3, 4 combination. 3, 3, 4. Or going the other way with the green would give us a 3, 4, 4. So again, you're going for the lowest combination, which means we need the 3, 3, 4 versus the 3, 4, 4. Hopefully that makes sense. If not, feel free to ask me about that. Now we have 3 methyl groups, so we're going to number them and we're going to say 3, 3, 4 dash tri, meaning we have 3 methyl, and then 6 carbon chain is hexane. All right, so this is a 3,3,4 trimethyl hexane molecule. That's it for this video. We'll see you in the next one.